thank you everyone for coming in. And if you haven't signed the sign-in sheet, make sure to grab it from Julian. Perfect. So today we have our first professor coming in to speak, Dr. Michael Leverington. You guys may have him in 480 or are going to have him in 249. So everyone just welcome Dr. Michael Leverington. I have something else to say, but
Well, thank you. I hope you're all looking forward to 249 and 480. Those of you that aren't already there. Oh, this is real. I thought this was a fake. Wow. They make them big these days. Okay, so Michael Leverington. I am a colorful guy in the sense that I really just could never find myself doing one task or job. I've done a lot of different things, which is kind of interesting because when I got out of high school and got at least tried to get into college, that in those days you started with a company at age whatever 22 or 24, and then you retired from them at 60 or 65, whatever, and you had your pension and everything. And that's just never going to happen again. But I broke the mold at the time because I fixed cars. I started a Better Business Bureau. What else did I do? I did a lot of flight instruction and a variety of different things. And so I've been back and forth in various kinds of industries and academia. It was when I was teaching people to fly that I really thought it was kind of cool to teach. And so I thought, well, I'll go get a degree and I can go teach. And as part of that process, they said, you can do lots of things. They do one of these interest inventory things. You can do this and you can do that, but the very top thing, standing on top of everything, was college professor. So I ignored it, and I went on to teach high school for a while. But it turns out I landed where I needed to be. So tonight, what I want to talk about, the last industry job I had, I came back to academia in 2004, where I started on a PhD, and then while I was at it, picked up a master's degree, and then while I was at that, got hired and started teaching at the University of Nevada, Reno. But the last company I was at that was a fluke too, because it was my wife that actually got hired there. She got her EE in 96 or 98 or something like that, and this company recruited her. And when we went out to see the company, they said, well, hey, Michael, what are you here for? And I'm just a husband. And they said, well, what do you do? And then I said, well, what would you like me to do? So the next thing you know, about 3 weeks later, I'm getting interviewed for being a technical trainer at the time. And that's what I started out with the company at. But then I went on to, what I was doing was, I was having so much fun. I'm a geek, it's a fact. But I would set up systems. We had a rotating systems. It's a little machine that could rotate as little as 100 RPMs up to 10,000 RPMs. It was cool. And we measured vibration on it. And we put it into monitor systems that I'll talk more about in just a minute. And I was setting these systems up, and then I was starting to fake data by taking the systems, the real data, and running it through spreadsheets on the computer and going back and forth and making it look like pumps and power systems and all kinds of stuff. Well, then a VP comes in and walks in one day when I'm doing a presentation, and he goes, who did this? That would be me. And he goes, you need to be in the field. So next thing you know, I'm a field engineer. That's what they called me. I'm not trained in engineering legally and officially. I do have CS degree, a master's degree actually, and a couple others. But the fact of the matter is, I got to do what I really like to do and what ended up being my PhD goal, and that is solving problems. And the last time I presented, I think it was last spring, I just picked up a handful of different problems that I'd solved over the years, and that was my presentation. Tonight, what I want to talk about is this particular thing I did for what was Bentley, Nevada, became GE. GE bought us 2001 or something like that. And I want to talk about kind of the concept of engineering versus techiness, teching, if you want to call it that. What I worked on was a thing called GE Power Smarts. And I was going to find you some pictures of GE Power Smarts on the internet, but when I Googled it, there you can find it in some text in a couple of places, but they really don't talk about it that much. I was never sworn to secrecy, so I think I can talk about it. I don't think it's proprietary, but anyway, that's what it was. And in a nutshell, what it was, you'd be at a power plant, and it was very specifically for power plants. And for GE, even though we did a lot of stuff with steam turbines, GE was really, really hot on, sorry I said that, but on things called gas turbines. Okay, what's a gas turbine?
It's a turbine that runs off gas.
That's pretty close.
So gas
It's a
runs-
jet engine mounted on the ground. Okay, it's if you call it a jet engine, it's probably hanging under the wing or on the side of an airplane or whatever. If you put it on the ground and you connect it to a generator or whatever else, it's a gas turbine. Same thing. But when you put them on the ground, you can put larger cooling systems on it. You can make it a lot longer turbine and get more efficiency out of it and whatever. And what GE was really interested in was highly refined tweaking. They did a lot of serious modeling of these things, and they wanted to get every single horsepower and therefore megawatt out of every little drop of mostly natural gas that they pumped into these things. That was really their goal. So to handle that, what they needed was to get real live data running 24/7. So they could be collecting it and tracking it, see what's going to, what history looks like, but also they could actually look at real live circumstances and see what's going on. So what happens is you come to this power plant, and somewhere in this power plant there's a control system. And in that control system, there's data, okay? They're pretty much, I don't think I did the same kind of control system twice in doing my projects, but the control system could be somebody's homegrown system, it could be a Honeywell system, control systems. GE themselves, for some of their own systems, had their own control systems. The trick was to get that data out of their system into a device. I'll go ahead and start drawing a picture here. Into my computers. And then out of my computers, we sent it to, am I drawing that? I'm drawing the arrow in the wrong place. Fix that real quick, if that matters. Out of my computers to the internet. Okay, where it comes back down in Atlanta, Georgia. Unfortunately, I never actually got to see this place, but as I understand it, it looks like one of those things you see in the movies where there's walls and walls of TV screens and monitors and stuff where they're literally watching power systems all around the world. Never got to see that. I fed it a lot of data, but I never got to see it. So anyway, my job, in a nutshell, was in some cases, I didn't always do the design front end, but probably 2/3 of the time I did. But in a nutshell, my job was to roughly design a system that would take the data from here, bring it into my own cabinet. I'd have some other things in here I'll talk about, and make this happen to the internet. Okay? So one of the things we commonly had to do, almost always had to do if somebody else didn't do it for us, was we had to do a survey. Because for every single one of these control systems, there's some kind of interface, some kind of data interface, all right? Meaning something to plug into, all right? And we had to figure that out. Now, there's two things about interfaces. Thing number one is, what's the plug look like? What's the electric part of it look like? RS-232, 422, 485. There was a thing called Modbus, we'll talk about in a minute. So I had to find out the interface itself, and then the protocol. In other words, how did the computer talk? What was the data that I'd get out of it? All right, and I'd have to do this in advance and figure these things all out, figure out the equipment was necessary, get that all figured out. There was some very canned things that were coming with every system here, and then and that was the advanced work. And for the most part, this was really just Legos. You took this part right here and you took that part. The artsy part of it was this right here, because every one of those was different, and you really had to figure out new things on those. All right, but there was a lot of it was plugging together, and I want to make a comment on that. because when you're working with Legos, you're a techie. Okay? When I came here, I would land in Attica, I'd land in Mejillones, Chile, I'd land in Mississippi or Florida, one of those other foreign countries. I'd land, wherever I landed, there'd be $150,000 worth of boxes in front of me, somewhere on the deck somewhere. And literally from nothing but boxes, I did mechanical work, I did electrical work, I did it all. I would build a cabinet here. I built a slot computer system here, which had at least one of our computers and sometimes more. And then we had a RAID system down here, basically a backup hard drive system here. Up at the top, and we'd also have power supply stuff somewhere down here. And then up at the top, we'd have some kind of networking stuff. And this is the techie stuff. And I want to qualify that. That's the techie stuff. And all that really is I'm serious, it's Lego building. I always tried to run the power cables down one side of these, and then the signal cables down the other side so we wouldn't get electrical interference. All right? So there's just some things that you just do as a techie. You just do these things to make it work. All right? But to give you an example of where the gears shifted into something else, one time they said, okay, Michael, and where was that? That was back east, I think. I don't remember where that was. But anyway, somewhere out there, they wanted to have a monitoring system in there. Where we had, at that time, two monitoring systems. One was the 3500 and the other was the 3300. And these are also slot card things where you just put them in and they measure stuff, turn them into electrical signals. They do digital signal processing for those of you double E's and anybody that's going to do a lot of math on a chip. They did that kind of stuff. But those were the monitoring systems, and quite literally, these are the control systems. If one of the things they measured was vibration, heat, some other things, speed, and that kind of stuff. If something went off the rails somewhere here, there was a great picture outside of my office of a rotor. Now the rotors for these steam turbines were multi-tons. They were massive, and they were so big around and really long, sometimes the long length of this room or whatever. And I had a picture outside of my office there on my cubicle where one had come out of the building through the roof and had landed about a quarter mile down the road, right next to where the road was here. And it was looked to me like to be about a third of the rotor. This is a multi-ton rotor that went airborne and landed a quarter mile away. All right, you can do some damage with these things. So the Bentley Nevada / GE later systems tried to keep that from happening. If we got vibration past a certain amount, it said no, and cut the power, cut the fuel, and off went, and the system came offline. All right, that was monitoring systems operations. So one time they said, okay, Michael, we want you to do all you're doing here, but we also want it to have the 3500 monitoring system in it as well. So as a techie, I could say, cool, give me the box. It's a Lego part. I'll put that box in there. I can wire things up. I can plug things together. But that's where you have to stop and say, there's actually an engineering problem here. Now think about what I've been saying and think about what might be a problem with what I'm packing into this cabinet here. What happens when you put a lot of electrical devices close together?
EMF.
EMF is a problem, but simpler than that, they get hot. Just normal operations, they get hot. So Michael turned from a techie to an engineer at that point, saying, sorry, I just moved it. All right. Michael turns from a techie to an engineer at that point and said, okay, what kind of heat does this monitor put off? We knew the components for the computer. We knew the heat output and so on. But I did not know what the monitor was in terms of heat output from 3500. Well, I got that number. And I said, that's probably not going to work. So I said, now what kind of airflow do you? Now we're talking about CFMs. All right, we're going to have this 300 CFMs or whatever it was. All right, so now we're talking about that. Well, now how are we going to solve that problem? And the answer is, we're going to cut a hole in the top of this box right here, on top of this rack, and we're going to put a fan in. So that's what I did on site. I had to take my tin shears with me, and I had to take some other stuff there. But this is where I want to talk about, and you are computer scientists, computer engineers, electrical engineers, whoever, but we're all engineers. When we're looking at something, we're saying, you know, we've got to look past what it takes to just plug things together. Whether that's a software design kind of thing. Anybody here in 480? I'm seeing, yeah, I've got some. So you don't just plug stuff together. You've got to figure out, well, down the road, it's going to have to do this. Or when we handle this, it's going to have to do that. That's engineering. That's real engineering. That's not techie. That's not Legos. All right? And that's a real key point to what I want to talk about tonight, is that concept of where are you at. I happen to like being a techie. I can do engineering. I can do lots of different kinds of engineering. But I like being a techie. I like plugging Legos together. I like wiring things up and seeing lights come on. It's cool. But there are times where you've got to get past that. You've got to say, wait a minute. I'm being paid to take a look at the big picture and make sure that this is going to work from now on. It's not going to work for a little while and fail. All right? Come back and talk a little bit more about that. So anyway, what happened there was I got numbers. I got heat numbers. I got CFM numbers. I had to check on power consumption quantities. I had to look on some other things because our power supply was built for certain things, so it handled under that circumstance. So I got all that done, and then when I got to the site, I literally had to take one of these big, first I had to build the cabinet, and once I got the cabinet built, then I had to cut a big hole in the top of it and mounted a fan and did things that techies do. All right, got that done and made that work, and it was pretty cool. I think, as I recall, I had to louver one of the doors or something like that too, or we cut something out so it would draw air and use natural convection as well as the airflow that we had. All right, so again, techie versus engineer there. All right, we'll talk about that in a minute. So one of the things about this that was standard operation, and this is me now being mostly a techie here in the field, because in the field you're still kind of designing some things on the fly, but you're mostly putting Legos together. You're mostly plugging things together. And one of the things about a power plant is if a power plant's up, it's making a lot of money. When a power plant is down, it's losing a lot of money. There's no neutral ground. All right? And so what they don't like to do is have the power plant be down, and what they do like to do is have it be up. And so what they do is they'll run a power plant, they'll run a steam turbine, they'll run it for 3, 5, 7 years. All right? They'll run them a long, long time. But when they come down, they'll take them offline for 1 to 3, and it might be a whole month, 1 to 3 weeks, 4 weeks, something like that. And it's not only expensive that they're not making power, they're losing money on that part of it, it's also very expensive because at that 5 or 7 year period, that's where everybody comes in and does the maintenance. They take steam turbine apart, or they replace a rotor, or they put in new monitors to whatever. They want that to happen really fast because they want to be making positive money again as soon as they can. All right? So what I had was 7 to 10 days. I don't think I ever had more than 10 days to make all of this work at any given time, wherever I was. All right? And so I usually did get anywhere from 2 to 3 or 4 months in advance. I could usually run out for a 1-day survey if I'm the one that did the survey. But this was my job to do all this stuff in 7 to 10 days. And you know, I'd love to show you a bunch of pictures. It didn't occur to me to take pictures because you get up at 6 in the morning, you get breakfast, and you go out there, and then sometime that evening, usually when you just can't work anymore, or the restaurant's going to close, you get home and get your dinner eaten. There's no I'm on vacation here. You're at it, and I love that. I really enjoyed that. I'm not knocking that part. All right. And another thing it taught that turned out to be fortunate for me in Chile was that steam turbines, they are very large machines, and you don't just turn on a switch to fire them up. You start rolling them at a very low RPM, and that can take a couple of hours to just get them going up to 2 or 3 RPMs. And then you start slowly bringing them up, and it can take anywhere from I don't think probably less than 4 or 5 hours it can take a day to get one of these things cranked up. I worked on a couple in, where was that? Started with a T. It's actually where Colin Kaepernick came from, Temecula, Turlock, California. I worked on a gas turbine there that they could actually fire up and be running in an hour. But the heat shock of the system was so violent, they hung their cooling water tank from cables because they couldn't just mount it on the ground. It grew too fast, the expansion and so on. So, but that was uncommon. Usually it took a long time to get these guys started up. And so, and you'd be working along with that. So then I got a little note here under what I called curveballs. One of them was a monitor in the cabinet. Another one was, for a couple of things, we had some other software in here. At those days we were dialing up with modems. And so we had to get a phone connection. And I had to go, I'd be climbing into walls and ceilings and all kinds of stuff in power plants, trying to pull a phone cable through. And then, of course, I had to have all the connectors. I had to make my own connectors for everything. That was a curveball. The internet was always a curveball. Mexico, Monterrey, Mexico, and Chile, Mejillones, Chile, and some other places like that, they just don't have an internet connection. So out back, they build a little fenced area, and they put up a great big dish antenna, and they point it at somebody's satellite, and that's their internet. It was, in those days, I think it was something like 256 kbytes to 512 kbytes down, and it was something like, I think it was, the max was 128 kbytes per second up. Very, very slow, especially for the data I needed to communicate, because I wasn't the only one using that satellite dish. All right, so there were tricks with that, and we had to make sure that we weren't getting in the way of other controlling systems or other problems there. I did have one, I think that was in California. I had done the engineering on that, designed the whole thing, got it all ready, and I got out to it. Interesting place, Stanford University. Stanford University has a power plant on campus, all right, and they make power there. It's not a real big one. What they do at nighttime is they make ice, all right. This power plant runs all night long and makes ice in a building right next to it, and the building right next to it just gets filled with ice, all right. Then during the day, they just put a big blower on that, and they push cold air around the system. That's their air conditioning system, and then they make electricity for the rest of the world, the rest of the system, for the rest of it. Well, I went into that facility knowing exactly how I was going to put that cabinet in and how I was going to set it all up. And the guy meets me there, and he says, yeah, I something I need to ask you about here. And he takes me over to this room, which really would have been a nice place to put the cabinet. And he said, we're actually going to use this room for something else. We need you to put the cabinet somewhere else. Okay, give me some examples of somewhere. Turns out I put it in kind of a hallway upstairs between offices. And of course, all the wiring was different, wire distances were different. There's so many things you're doing when you're in the field like that. You're on the fly, and to see the pants flying. It's cool stuff. It's problem solving. For me, it's just problem solving. I'm in it. I love that stuff. But a bit of a challenge, the more dragging around cables and stuff. And I'll come back to that one in a second here. One of the things that I really want to point out about any kind of engineering, techie kind of stuff is that you just, if it's of any consequence, you're not going to do it alone. You're going to be scheduling things. You're going to have to know that you can get this equipment shipped, how fast you can get it shipped through customs. It can take 2 or 3 weeks to move from that side of a building to that side of the building in the customs area in South America or whatever. You've got to know that. You've got to know how that's going to work and the paperwork is going to work. My goodness, the first time I went to it, which one was it? I don't think it was Mexico. Probably, it might have been Chile. I landed in Chile, and I didn't know you had to fill out visa paperwork. And I'm supposed to know the name of the person I'm meeting, which I've got all on my laptop. I literally have to stop in this long hallway where you're supposed to be walking through with your passport. I pull out my laptop, and okay, here's the name, here's the address, here can fill it in. Now I learned the first time, on my own, on the fly. After that, I filled that stuff out on the airplane coming in. So these are things that you're evolving, you're growing, but you're still not doing it alone. You're trusting other people are going to get things shipped. You're trusting other people are going to know that takes 2 weeks, not one day less. It's going to take 2 weeks to get that from that side of the building to that side of the building in Chile. And we're going to do those things. So you talk to those people and you interact with them. The equipment that you're going to have, sometimes you get there and they say, well, we just don't have access to this, or we don't have this power access or whatever. What are you going to do? You're going to solve a problem. You're going to probably go out to one case, out to their shipping deck, which is where I did some of my manufacturing, because that's where they had the power I needed. all right? And so you deal with that kind of ups and downs kind of stuff. But these people are helping you. One cool thing about South America, I did Ecuador, I did Chile, I did Argentina. I think there's another one, but I've forgotten it right this moment. But is the people there are cool. The people everywhere are cool. You meet them face to face. You meet them at their level. And it was funny because my Espanol was pretty good in those days. I could order on and off the menu at the restaurants, and I was pretty good. Today, not so much. All right? But the funny thing about it is here I am. Boy, I'm going to really make my Spanish be better this time. And they get down there and they all want to speak English because they want to learn English. And so I literally was talking to people about the difference between he and him and her and let's see, she and her in English. Why would you use one or the other? Because I was teaching English when I was doing it. But the people are cool and they want to talk to you. And so we interacted. I never drove. I never wanted to drive in South America. I didn't even drive in Mexico. I got either in Mexico, I had a driver. I just had somebody I paid to, he took me back and forth and wherever. In South America, I got to know some of the contractors and so on. I just hitched a ride. We rode back and forth. And so they always wanted to talk. They wanted to practice their English and just visit. And hey, where do you live? I live in Reno. I live in Nevada. Well, what's that like? Is that like Washington D.C.? No. But you know, cool things to talk about and cool people to work with, and you get to meet them. There was one guy. How many do I have my time? I'm gonna keep an eye on that. I met Roberto. Roberto, I actually met in Chile, and a project manager extraordinaire. He had everything under control. He had people from 3 different countries, I think, working for him, and contractors and subcontractors. He had it under control. He bit me one time in Chile that threw me a curve that I had to deal with. But just a fun guy. And we talked, we interacted. Hey, Roberto, I need power here. Okay, I'll get a contractor over there. I'll get that. Bam, bam, bam. You know, always had it under control. And it was so funny because I landed in, I think the next one, I think it was Argentina. It was in Argentina, and I just got in there, and I was cold. I didn't know anybody I'd be working with there. And so I'm at the hotel, though. It's in the hotel where all the contractors stay. You always knew those hotels. And I came in, and I found some guys, and I said, okay, you're working on that project. Usually everybody was working on one project. It's a big deal. And so I say, I want to hitch a ride with you out there. No problem. We're going to get breakfast. Well, I was up early. I had my stuff out. Ate my breakfast. Got my teeth brushed. Got everything ready to go. Got my 70-pound, my 69.5-pound toolbox, because it can't be over 70 pounds on the airlines. And I had that down beside me and a couple things. And I'm sitting there, and the elevator door opens, and Roberto walks out. Dude, hey, I know somebody here. Oh, Michael, I got to take you in. I'll drive you. And we're there. It's just you're just there, and the people you're working with are you don't want to let anybody down. You want to work with people, and you want to share what you're doing because you've all got a goal, and it's a common goal when in a project like this. And so that was just plain fun. We had a good time with that. Lots of stories told and so on. But I'll come back and talk a little bit about that later. But it leads me to what I hear need for people all along the way. Who knows Wally and Dilbert?
Wait,
What's that?
Not the Disney Pixar.
No, not Wall-E.
No.
Wally.
Like the
In Dilbert.
Like
little
the
cartoon, the comic strip,
Comic
like
strip.
with the guy that his tie went up like that, right?
That's Dilbert.
Yeah.
If you are not reading the Dilbert comic strip, you need to be doing that. That man has spies. For one thing, it's generally agreed he has spies in GE. All right? He knows what's going on. And he has Wally. Now, Dilbert is the geek. Dilbert is the engineer, the frustrated engineer. There's all these other characters. But Wally, to me, I've been teaching Wally since I started teaching college. Wally is the guy who walks around with a coffee cup in his hand all the time and never does anything. All right? And you can, I catch comics every morning, and it's on the AZ Comics, free comics thing if you want to get on it. But Wally, it never does anything, but he always tries to make it look like he's doing anything. You're going to have to deal with Wally. And you may have already done that here as a college student, but you're definitely going to do it with a lot bigger what do you want to call it, requirements or problems in industry. It's going to happen, all right? But the Wallies are few and far between. And sometimes even the Wallies have something that can help you out. And so what you do is you network. You communicate to everybody, and you keep a real positive attitude. And you say, so how's the coffee today, Wally? Or whatever. And you make those connections and those friends, and then somewhere along the way, Wally says, you know what, Michael? I've got something here that can help you do such and such. And you make those connections and you make those friends. You just don't do this stuff alone, if it's of any significance at all. And so I think that's very important. I said, consider Wally, consider everybody else, all right? The great people. And they're all great one way or the other. And you need them. And they need you. That's the cool thing. It's symbiotic. All right? And you work to find those people, and you work together with them and discover Roberto in 2 different countries and get to tell stories. Roberto did bite me one time. I had the system up. This was in the corner of a tiny little office. Probably the whole office itself was probably don't big. 2 desks over here, cabinet over here, my little corner over there where they dug something out to put my cabinet in here, and that was where I was going to put this system in. I had to bring wiring in. Fortunately, a couple of places had fiber optics, which I'll talk about in a second. But I brought all kinds of stuff into that place, and I put that cabinet in the corner. That is a cabinet. When I told the story last spring, that they had the people. This was one I had not done the survey on, but I had done the engineering. I done all the design. I specified everything, and the people that shipped the stuff just plain forgot to do what's called it's a resistor, but it's a specific resistor. It's an ending. It keeps electrical reflection from happening. But it went on the RAID devices on the bottom. It's really about a 75-cent or 85-cent resistor. They charge about $50 to $100 for them because they're special to go on the backs of RAID systems. And it turned out they didn't send one. I mean, I go, okay, it's missing. Somebody dropped, because it's not big. And but we go through all the packing, oh, we forgot to send that. And I call up Atlanta, Georgia, and I had at that time a analog cell phone. Okay, we weren't well into digital systems, digital cell phones at that point. I had an analog cell phone, and I got to tell you, when you're on an analog cell phone for 2 or 3 hours, it gets hot, especially if you're in a foreign country where the cell system's pretty far away. I was on that system for at least a couple of hours, 2 or 3 hours, one afternoon, started the conversation with, I need somebody here with a resistor in their pocket tomorrow. And they said, no, that's way too expensive. We can't do that. And they talked, and I said, do you want this system running? Yes. Well, can't we do this? No. Bottom line, about 2 or 3 hours later, we wrapped it up with, okay, I'll be seeing Bill, whatever his name was. We'll pick him up at the airport tomorrow morning. And poor Bill worked all day long that day, and then flew all night long that night, and handed me 2, not just 1, but 2 resistors that next morning, which I went ahead with. That's the kind of problem you're solving on the fly, and that was a $3,000 solution for a 75-cent resistor. All right? And so but that kind of stuff happens. Well, that had set me back just a little bit. They were going to spool the steam turbine up on Sunday. They were going to fire that baby up on Sunday. And I was closing in on Friday, and I think it was Friday that we got the resistor in. And so I got that going. I couldn't start anything. This is the hard drive system. Couldn't do anything computing-wise. So once I got that in, then I could do da-da-da-da. And we came in on, I think that was a Saturday morning. We literally ate breakfast as soon as they opened the restaurant, and we hightailed it down. Mejillones, Chile is a village. It doesn't qualify as a town. And the one street that kind of goes through it goes straight out the road to about a half a mile to a mile to the power plant. It's easy to find. All right. So we were out there early, and we were on it, and I had an assistant that I was training there. And so we got out there, I got that, I had the thing from the day before, so I had the computer up and running. Now I had to make the interface stuff work. And one of the things I did, I was going to dig it out of my toolbox, because I know I just saw it recently. I had made myself a little plastic, it's a rubber, you can buy these now, they're a rubber head with fiber optic sticking out of it, and you could put it on a flashlight, on a little flashlight, and you can actually make fiber optic little tiny light. I had made that, and I'd put a little windshield washer hose on the end of it. So I could plug it on the end of fiber optic cable that didn't have a regular end on it at that point. I guess I could even do it on real ends, because they could end. But I plug it on the end, the regular old flashlight, turn on the flashlight, and then go to the other end, which could be halfway across the plant. And you'd see light out. That was the amazing thing about fiber optics. It's tiny little fiber, but it's got light at the other end. And I did this. What happened a lot of times, we had a thing called Modbus, which I'll tell you about if I've got some time here. But the system here, you had a TX and an receive, whatever, RV, RCB, whatever, and then a fiber connection and a fiber connection. Now, the techie level solution to making this work was, here, plug this in here and plug that in there. Does it work? Oh no, okay, unplug them, swap them around. Does that work? Oh, okay, now we're good. That was how I was trained, that was how we dealt with it. I was a little uncomfortable with that. Me, with the engineering kind of blood that kind of ran through me a little bit, I was a little uncomfortable with that. So I actually made this little flashlight thing, and then by golly, I knew that what came out of TX on one end in a building about a block and a half away to the RCV, whatever it was on my end, I knew which one was going where, because I couldn't test the system while I was doing all this other stuff. So I put that all together, and I set that all up. And one of the things that was happening, and I didn't know this until later, which is probably good. This power plant, if you know Chile, it's about 1 inch wide and about 20 miles long. All right, it's just follows the coast of South America here. Well, this power plant's roughly here. I did not know until I read about it later on. This power plant powered all of northern Chile. And the power plant itself, I mean, most power plants, if you bring your power plant down, you just hook it to a grid and you get power from somewhere else. You can't do that here. There's not a grid. So when that power plant was down, there was no electricity there. They themselves, to have electricity, had to fire up diesel generators. All right? So key point here, if this goes down, this goes dark. All right? Well, this system, we had half of them down. They had, and I believe that was, they had an interesting combined cycle with efficiency. They would burn gas and run 2 gas turbines, take the exhaust from that, add a little bit more fire to it, and boil water, and run a steam turbine off that. They were scavenging the heat out of the jet engines. Really cool idea, actually. And so, but they had two sets of these. They had this set over here on like city blocks, this over here, and then this over here. We were working on one side of it. But they wanted me to set it up for the other side. So I did that. I put all the Modbus in. Definitely couldn't test that. It was already running. Couldn't touch that stuff. But what I could do was put my Modbus box in here, set up my fiber optics, set everything in, and put huge red tags on everything. Do not turn this on until we come back and look at it, check it out. All right, and which would be when they bring that side of the system down later on. So fine, set that aside. I get all this other stuff done, and I'm really just getting into testing the data. We went to lunch. That was on that Saturday, I think. We went to lunch, and we came back, and I still had just my little shopping list. Fix this, tweak that, set to do the software. And I come in there, and I was hearing a different kind of sound. I've been near a power plant. There's always constant noise. But I was hearing a different kind of sound. And Roberto was on the phone. He was talking to somebody, and he says, okay, we'll start spooling it back up a little bit more. And I said, spooling what up? Hey, Roberto, what are you doing here? He said, oh, well, we're firing up the machine. No, you're not supposed to do that till tomorrow. All right? Well, we're ready to go, and they can't wait. I mean, if it's ready to go, they need to get it started up because there's always testing and there's always a possibility it's got to come back down. But there was a very good possibility that machine was going to come up and go on for 7 years that afternoon. All right? Well, there you go. They throw curveballs at you. Well, I got all this stuff. You prioritize. The things that have to be working before it's running, you get all those working. I had it working. I was actually starting to collect data, even though it was rotating. They were actually spooling it up to a couple hundred RPMs. If you're not familiar, steam turbines commonly run at 3,600 RPMs. Why? What's the frequency output of your outlet? Come on, geeks. 60 hertz. 3,600 RPMs gets you 60 hertz. Turns out it's 60 times a second. Okay? So, just a little side note. In Europe, it's 3,000 RPMs, and sometimes you can double or halve or whatever. But anyway, they're running a couple hundred RPMs, and I was watching data come through. Life was getting good there. And so we worked that all through that, and then the machine what they were doing is taking it up and bringing it down, doing testing, and I was able to finish up the rest of the really important stuff that afternoon. And then they never, I don't remember, I think they actually never really did bring it up fully online until Sunday sometime, but I didn't care after that. I had it ready to rock. I had it ready to go and dealt with that. There's a little side story to that comes about 6 months later. I'm best friends now with the plant manager. I got to know everybody in there. I was teaching English to an entire control room for a while, just to get to know everybody, and that's cool. And the plant manager calls me up, and he says, Michael, he says, I've got your Modbus system turned on and all ready to go, and he said, but I need to know how I set this up. And I go, well, I already had the Modbus system on. He says, no, he says, I've got the other one that you set up. And he could have brought the plant down. If I hadn't set that stuff all up exactly right and put my fiber up, and I just did that a little extra call right there because you never know what's going to happen. And he sure enough pulled all those tags, all this red and orange that I put all over all these things, pulled it all off, ignored it, and turned it on. He's a good guy. I mean, great guy. We had great laughs together and stuff. But you go, man, are your turbines still turning? But that was just kind of an offset on that. But he was calling me up to ask me some questions about what they were going to do with it next, because that side of the system was supposed to go another couple of years. But they were actually started collecting, as soon as they turned it on and made it go, they started collecting data, and that was one less job we had to do after that. So some other things here that I wanted to talk about, and I'll talk about, I've got that at the bottom there, and let's see, where's that other one? Yeah, did that. So travel management by itself. There literally was one time, it was the Mexico job, I was working a regular old week during the week, and it was literally Friday afternoon at like 4 o'clock. We were having a conference call between Mexico, back east, probably would have been Atlanta, or it could have been, there's New York, we had a facility in New York too. But we had a conference call, we're all in this conference call, well, we need to do this, we need to do that, and then the plant manager says, well, this machine's gonna be back up on Wednesday. And we don't know when it'll come back down. It's gonna be on at least for a few years. So Michael, can you be in Monterey on Sunday? And I was in Monterey on Sunday. And they got me the boxes. They did some amazing things to get that. Again, people all working together. They got me some boxes shipped down there. And again, on fire. Fortunately, I did have my own driver on that. He even drove me to lunch so I could get in and out and go on there. But all of these travel kinds of things, on Sunday, on a Friday afternoon, you say, wait a minute, how do I get to Monterey, Mexico? And you start calling airlines, or you start looking online for airlines. In these days, the online wasn't as strong as it is today. But you do the action and the travel management. And again, at the time, the company, to start saving some money, they had a travel agent literally at our company. But they were kind of retiring those people out because, hey, the technology was there, you can do your own travel arrangements. But I gotta tell you, if you got a travel agency, use it. They know stuff, all right? And so again, that's where the people contributed. That's where people working together was really important. Talked about that. The pressure situation, there are some high stakes here. You can break things, and you can break big things here potentially, especially on the monitoring part. And I think I'll have time to talk about something happening on that. But on the monitoring, if you put those monitors together, set them up wrong, you can bring a power plant offline when you didn't mean to, and it costs a lot of people a lot of money and harm. But the pressure environment is there, and you live it. You just get down there at 6 in the morning. You got X number of things to do by 6 in the evening. Do it. Just get it. You got to just do other. Don't let it be pressure. Let it just be okay. Cool. I can do this and get it done. And so I talked about that. And then the one other thing I did want to talk about, because I just can't help myself from teaching where I can, This concept of Modbus, did I write that down somewhere? I don't think I did. Modbus, you want to Google that, you'll find lots of stuff on Modbus. Modbus was a serial, well, actually, effectively, it was a serial interface kind of system for some of the things I did, fiber, it did lots of other things. But Modbus was a deterministic system. What is a deterministic system? If you give it a certain goes into, you are guaranteed exactly a certain comes out of. All right? Ethernet is non-deterministic. Okay? And obviously wireless isn't either. Ethernet is non-deterministic because Ethernet allows for collisions. Your packets don't always make it. In fact, regularly collide and have to be reset. So when you send some data out in Ethernet, you are not guaranteed when it'll get back. That's not a good way to run a system that could, in a quarter of a second, send multi-ton shaft through the roof. I did go to, I don't know if I told this story before or not, but I did go to a place in Hawaii where when I was working with the guy, he said, yeah, here's our brand new steam turbine. This is a little guy, 35 megawatt. And he said, this is a little guy right here. He said, the other one went through that wall right there. And sure enough, there's a great big metal patch in the wall. I mean, big metal patch in the wall. But where you can do harm and you've got to respond in a measured amount of time, non-deterministic doesn't get it. Modbus is deterministic, all right? Modbus guarantees you, I used to teach some stuff on old star ether, on star ring token and star token kinds of networking systems, but they're guaranteed you will get your signal through in a certain number of milliseconds or whatever, all right? And you're guaranteed that's deterministic. And when you're running a control system that's, like I say, part of the control systems in this house over here, the power plant, the actual generator, he's on the next block over, literally. All right, these are city block areas that got these power systems around. So you have to have deterministic, and I wanted to talk about that about the difference between deterministic and non-deterministic under that. And the other one thing I wanted to talk about was, again, one more curveball. The 3500 system, I wasn't there when it came out, but as I understand it, it came out in about the mid-90s. The 3300 system had come out in something like the 80s. The 3300 system was still a cool system, a really powerful system. These are monitoring systems. They give you data about your machine, and they can stop your machine if something goes dangerous. Okay? But it was more analog. The 3300 had digital stuff on board, but it had some more analog. 3500 was almost pure digital in the system there. Well, I'm at a power plant. In this particular one, I was doing. In fact, I don't think I was doing a Power Smarts there. I think I was actually doing one where we just simply put the probes in the machines. You had to go out on the machine, sit on the machine, measure probes. You had to get them a certain distance electrically. I was doing some regular old, just again, techie stuff. And I did pretty good. Got the job done. I measured the probes. They have to curve them and all kinds of stuff. And I'm a little bit early. It's like 3 or 4 in the afternoon, and that's early in the day for a lot of people. And so, hey, Michael, I've got a tachometer here in our control room that we got it refurbished. Got it completely rebuilt by Bentley 2 or 3 years ago, but we never got it to work. And I go, I don't want to try to work on that. So how can I get out of this? I'll get them. Do you have the manuals for this? Nobody ever has the manuals. Sure, yeah, we can go get the manuals. He brings the manuals to me. And part of the manual says, well, you have to do this thing right here with this oscilloscope. Well, this would have been about 5 to 10 years after the most recent time I'd seen an oscilloscope prior to that point. I can use an oscilloscope. I can put one together right now. I'm not going to do it quick. All right, well, yeah. Do we have you don't have an oscilloscope here, do you? Oh, yeah, sure, Michael, we'll get you. It's all there. Okay, Michael, it's on you. So I start reading the instructions. You ever heard that before? Called reading the instructions. One line at a time. And it said you have to get this signal out of it into the oscilloscope. That's all you have to do. You hook this to this oscilloscope and you get this signal out of it. And it actually had a test system on board that gave you a dummy signal. So line 1, connect these things to these places. Line 2, do this right here. Line 3, set this signal at this point. Line 4, set such and such connect, probably an adjustment pot of some kind. Set this pot at a place where the signal reduces down to a certain place. Then bring it back up by 0.3 volts or something like that. I did it. Dang it. That tachometer worked like a champ. Okay? Much to my surprise. I think they just expected, oh, this is a Bentley guy, he can do this. They were wrong. But I did it anyway. All right? And so one of the things that I really thought I was in the corner on that one. I really did. And you will too, if you're in CS249 or CS480. But you just one line at a time. Follow the instructions. Get it done. One step at a time, no matter what the pressure looks like. One of the things to kind of reduce pressure is if the professor says, you should start working on this today, I'd start working on it today. All right? I keep having students, I get taught a lot. I have students teaching me all the time. Boy, Michael, if I started this a little bit sooner, I'd have done so much better. You know, oh, Michael, I wish I'd started this last week. They teach me, but I already knew it. All right? But seriously, there's a lot of places where you're going to feel like you're in a corner. Here, or out there, wherever there ends up being. And you stop and you say, okay, what have I got in front of me? What can I work with? Never in a million years thought they'd have a manual. They had a manual. And all right, one step at a time, and you fix it, you do it. And that was just cool. You know, I just did that. And I you know, it was kind of funny because the rest of the story is I'm hoofing it across that in the Monterey, Mexico, it's a completely closed system. Most power plants have a river or a lake or something nearby where they dump their water. They cool it down to a certain level and then they put it in the water. Not in Monterey, Mexico. There ain't no water around there. They truck it in. All right? And so it's a completely closed system. And it has a radiator, oh, I don't know, 30 or 40 feet, maybe 50 feet in the air. And that radiator is probably 3 times the width of this and maybe 50% longer than the length of it. And it's got, the fans are probably 36-inch fans, and it's got 1 million of them. I don't know how many it had up there. And that was their cooling system, and it was completely enclosed. Well, that's a long story way to get around to what's under it. Because they just really had a really nice looking power plant, and they had white 3-inch gravel under that. Looked really nice. You can't roll a 70-pound toolbox across right 3-inch gravel. So I pick up that 70-pound toolbox and I start hoofing my way about a quarter mile down the road here, and I'm going, yeah, I'm pretty good. I'm pretty tough here. This looks good. And I keep going and I keep going. And you know what? I was doing fine. Physically, I really was doing just fine. But about halfway, maybe 2/3 of the way across the trip, I started thinking to myself, you know, I'm this okay right now. Wonder how I'll be in 10 years or 20 years. And that was part of what drove me to go back to academia. All right. And so one of the things about being a techie is it's hard work. I like that part. But you need to make sure that you're keeping an eye on the future and the prize, where you need to go and how you need to make yourself better as you go along. In the current working environment, very few people are going to be permanent employees, even if you wanted to be, and you probably won't, because you'll get into one system or one project and you'll work on it for a year or two, or maybe 6 months or whatever, and then another project's going to come along, maybe within the company. GE is a great place to start. They'll put you anywhere on the planet doing pretty much anything you want to do. All right, I'm not a big salesman for GE, but for reasons I'll talk about in my office. But I will tell you, I recommend it to students coming out of their first degree, because man, can they get you started, and then they can put you. One of my fellow colleagues worked in France for a couple of years, where they have wine for lunch every single day. All right. And so there's different places, different places you can go and things you can do, but you're never going to get stuck in one place. And you need to stay light on your feet, and you need to always be growing and always be figuring out what's going to happen the next time they get you in a corner, all right, and how you're going to handle that. And the real bottom line is it's going to be on you. You're going to just say, you know what, I can handle this. Where's the manual or whatever. All right, that's my story about being a field tech. What do you think?
Nice.
All right. Any questions? You can always come by the office. I tell stories in the office as well. All right. Well, thank you very much. I appreciate it.
All right, so just the one announcement that I can think of off the top of my head right now is we have the T-shirt design contest up now. It's a Google form. Just go to nau.edu/ACM. It'll be right underneath the live stream links. And well, at the end of it, you have up to 3 choices. So pick 1 to 3 of the designs that you like, and they'll go to like the finalist round if we have to. And on top of that, just to entice people, we're giving away an Amazon gift card. Just read the details on the rules and regulations on that page, and we'll be good to go. Very cool. Thanks for coming, guys. Have some more pizza, relax, talk, whatever you guys want to do, and have a good night.
Underneath the live stream.
It says it's underneath the live stream links on the homepage.